Welcome to the deep dive. If you're building infrastructure with Terraform, you know that satisfaction of defining resources. You've mastered the basics, resource provider variable.
Right.
But today, we're moving past just defining single components and really stepping into systems architecture. This is where you level up.
It really is. It's the difference between writing, say, individual lines of code and building entire standardized libraries.
Okay.
I mean, if you think of your standard HCL file as a recipe, today we're moving past writing recipes for single ingredients.
Like just a database disk size or something?
Exactly. And we're talking about standardized meal kits. They come with all the side dishes prepackaged, ready to assemble. That kit is the module.
I love that comparison. So for the listener who wants that technical definition, we are talking about a module as a package. It's a reusable container of Terraform configuration files. And that container holds everything for a functional component. A VPC, its subnets, security groups, route tables, it's all bundled together.
Precisely. We are escaping the tyranny of that single monolithic configuration file.
And our mission today is to give you the knowledge to fully leverage this power. We're covering how to standardize, customize, and I think most importantly, connect your infrastructure using these components.
Let's do it.
So let's dive deep into the why first. I think the central question that holds people back from using modules is this perceived complexity. I can just see an engineer saying, look, I can take all my code, throw it into one huge main.tf file, and just deploy it.
Yep.
Why should I bother with this extra layer of abstraction and all these folders? What's the real incentive to move away from that?
Well, that kind of simplicity is often the enemy of scalability.
Yeah.
If you stick with that single file, you get what I like to call instant infrastructure spaghetti.
Right.
And when that environment hits a certain scale, it just becomes a maintenance nightmare. Modules give you 3 huge interconnected operational wins.
Okay, let's break this down.
So first, reusability. This is the most obvious benefit. You invest the time to build a perfect setup once, for example, a compliant, securely hardened web app config that meets all your internal standards. Once that's validated, you can call it 10 times across 10 different projects, instantly.
So you stop the copy-pasting.
You stop copy-pasting, and if you find a bug in that initial perfect setup, you fix it once in the source module.
And the fix just propagates everywhere on the next run.
Absolutely. Which ties directly into the second, standardization.
Okay.
By forcing teams to use the same module for the same task, you ensure consistency. You make sure everyone's adhering to company best practices, like required tags or mandatory encryption.
You eliminate that configuration drift that always seems to happen.
You do. The kind that starts when one engineer forgets one little security requirement or names a resource wrong. With modules, best practice becomes the default.
So it's not just saving time. It's actually a critical security and cost governance tool. If you can't standardize tags, you can't report on costs accurately.
Exactly. And third, organization. If you have 100 cloud resources, having them grouped logically into, say, 3 or 4 modules, network, database, application, it just makes the code base dramatically easier to navigate. It lowers the cognitive load for anyone new joining the project.
Fantastic. Okay, so I'm sold on the why. I need a module, but I don't want to write it from scratch. Where do I find these pre-built setups?
That's where the Terraform Registry comes in. You'll find it at registry.terraform.io.
Okay.
Think of it as the public library for pre-built configurations. It's where verified providers like AWS, Azure, HashiCorp, they all publish modules that are guaranteed to follow best practices. So for you, the listener, if you're deploying something standard, always check the registry first.
Okay, so I found a module I like. Let's say it's a verified module for a secure S3 bucket. How do I actually bring that code into my own configuration?
You use a specific piece of Terraform syntax, module block. It's pretty easy to read, but the most crucial argument inside that block is the source argument.
And that's where Terraform finds the code.
Exactly. The source tells Terraform where to download the module from. It can be a few different places. It could be the public registry, a Git repository like on GitHub, or even just a local folder path on your machine while you're developing.
Okay, wait a second. If I'm pointing to a public registry or a live Git repo, I'm relying on someone else's code that could change at any time. So you're telling me a random update to that source could just break my production infrastructure.
That is the crucial point here, stability. If you're running this anywhere near production, you absolutely must use the version argument inside your module block.
You have to pin the version.
We can't stress this enough. You have to pin your module versions.
Can you give us an anecdote? What's the real-world consequence of not pinning a version?
Oh, certainly. I remember a client who deployed a new cluster using a community VPC module. They didn't pin the version. A week later, the module owner pushed a minor patch. But in doing so, they accidentally changed the default naming convention for a few subnets. The client's nightly pipeline ran Terraform apply, saw the change, and just renamed the subnets.
Oh, no.
Suddenly, all the firewall rules and routing tables that referenced the old subnet names just broke. It took hours of debugging on a Saturday morning to figure out that an external unpinned module was the cause.
So the version argument is really a non-negotiable security control. It locks the dependency.
It does. And since you mentioned downloading the module, what's that essential step you have to perform every time you change the source or version?
Ah, good point. That's the one that always gets forgotten.
It is. Every time you modify that source argument or change the version number, you must run the command Terraform in it again.
Right.
Terraform needs to reinitialize, download that new source code, and make sure it has all the right plugins before it can even run a plan.
Okay, let's unpack our next challenge. We've established that modules provide fantastic standardization. Infrastructure is rarely one size fits all.
Right.
I've pulled a generic database cluster module. It's great. But what if I want one instance to be a tiny db.t3.micro for staging and another to be a massive db.r5.large for production? How do we get that flexibility?
This is exactly why we have input variables. Variables are the language of customization. You can think of them as the knobs and dials on the module.
Okay.
When you call the module, you provide specific values to these knobs to customize the result, whether that's instance size or the region or backup frequency.
So when I look inside a well-written module, I see that variable block. What makes for a really robust input variable? I think there are 3 key elements.
Yes, 3 key elements that make a module predictable and easy to use. The first is type. This ensures data integrity. It defines what kind of value is expected, a string, a number, a bool, or even complex types like a list or map.
So it prevents errors. If you expect a number for disk size and someone types large, Terraform fails right away.
Fails during validation, not hours later during an apply. It's a huge time saver.
Now, if I'm defining a default value, why do I also need to define the type? Doesn't the default value kind of set the type for me?
That's a great question, and it's all about being explicit. While the default gives a hint, the type is your strict contract. It acts as validation for any input. Plus, for complex types like a list or a map, you can pass in whole data structures, like a list of security group IDs. That power really requires strict typing.
That makes perfect sense. The type is the safeguard. What's the second key element?
The second is default. This is your fallback value. If the user doesn't provide an input, Terraform just uses this. It makes modules much easier to use quickly.
And the third element is purely about maintainability, right?
Yes, the third is description. This is essential documentation. It tells the team exactly what this variable is for, what values are okay. Good documentation is the difference between a tool people trust and a frustrating black box.
So once these variables are defined inside the module, how do we actually pass values in? I know we have command line options, but that feels messy for production.
You're right. You can use a command line flag like nekisvar instance size t3.micro. That's fine for a quick test.
But if I have a module that needs 20 different inputs regions, subnets, key names, that command line is just going to be a disaster.
Absolutely. The preferred industry standard method is using dedicated .tfrs files. This file holds all your variable definitions in a clean declarative format.
And why is that .tfrs file superior operationally?
It's all about consistency and auditability. First, it separates your inputs from your logic, which is just cleaner. Second, you can version control it in Git. You can see exactly what parameters changed between deployments.
Which is crucial for debugging.
Crucial. And third, you can have multiple files like staging.tfrs and production.tfrs and just specify which one to use when you run Terraform.
Okay, so we've mastered sending data into the module. Now let's talk about the reverse, getting data out. The module has successfully created a resource, like a load balancer, but that resource has dynamic attributes that were just determined during deployment.
Right.
If I need that load balancer's specific auto-generated DNS name for something else, how does the module give that information back to me?
For that, we use output values. This is probably one of the most powerful concepts in Terraform architecture. You can think of an output as functioning just like a return value in a programming function.
Okay.
The module, on the inside, defines an output block to expose certain data points that the calling configuration might need.
So the module builder decides exactly what gets exposed. It creates a clean interface.
It creates abstraction, yes. You don't need to know how the VPC was built. You just need its ID. The output block handles that.
Okay, so once that data is exposed, how do I, sitting in my main configuration, actually access that value? What's the syntax?
The syntax is standardized and predictable. You reference it using the structure module.modulename.outputName.
Let's make that concrete. Say I named my module web cluster, and the output value inside it is LBDNs.
In that case, you would reference it in your main code as module.webcluster.lbdns.
And you can use that reference anywhere else you need it. And this is really the gateway to building truly complex systems. This is how we achieve infrastructure chaining, right? You're connecting the dots between separate services.
Exactly. Outputs are the glue. Let's walk through a concrete example of chaining, because this is where that major level up we talked about really happens.
Please do. Let's see it in action.
Okay, imagine a three-tier application. You start with Module 1. The network module. Its job is to build the VPC, the subnets, the route tables, and its output is the list of private subnet IDs it created. We'll call it private subnetids.
Okay, so the network module runs first, creates that foundation.
Next up is Module 2, the database module. Its input needs to know where to place the database securely. So we pass the output from Module 1 into Module 2's input.
Ah, I see.
The reference in Module 2's code will look like var.placementSubnets, module.networkmodule.privatesubnetids.
Okay.
Then the database module runs, builds the secure instances, and outputs its own critical data, the secure connection string, which we'll call DB connection string.
So Module 2 depends on Module 1, and now it has its own output.
And finally, Module 3, the application service module. This module needs the database details. So its input variable takes the output from Module 2 var.databaseEndpoint, module.databasemodule.db connection string.
Incredible. So by using outputs, you're not just provisioning servers anymore. You're orchestrating complex, multi-layered systems where one component feeds the next, all while keeping the code clean and encapsulated.
That's the true power. You've transformed dependency management from a manual headache into an automatic declarative process that Terraform handles for you. You build it block by block.
It eliminates all those errors from manually copying IDs or DNS names between files.
Exactly. The systems configure themselves.
That truly solidifies this entire discussion as a critical level up. We've moved from building single walls to defining reusable city blocks that can chain together automatically. For everyone listening, let's wrap up with the 5 essential takeaways.
Certainly. These are the 5 core points to commit to memory. First, modules are reusable containers. They group resources for efficiency and standardization. Second, the source argument is essential. It tells Terraform where to find the code, whether it's the registry, Git, or local path. Third, always pin the module version for stability. Do not leave this open-ended in production. Lock your dependencies.
So important.
Fourth, data flow is key. Use structured variable blocks to pass data in and well-defined output blocks to get data out.
And the last one, the operational step.
Yes. And finally, that crucial step. Every time you add or change a module source or version, you must run Terraform in it again.
Fantastic. So we've talked about how you connect the output of one system to the input of another. Here's a final thought for you to chew on. Since you now know how to standardize, customize, and chain these complex systems together, what massive multi-layered infrastructure project, something you previously thought was way too complicated, could you realistically start building tomorrow?
The power is no longer in the resources. It's entirely in the chaining. Happy coding.
See you in the next deep dive.